Hi guys, so in this video let's talk about a very important issue in academia, which is the ever-widening communication gap between academia and society. So recently I attended summer school on quantum mechanics, and I talked with a lot of physicists and professors and even people who are not in academia, like people who are in industry, who are in defense, or even some people who are just kind of spiritual kind of people. And I talk with, yeah, I am not usually a fan of those kind of things, but it's all right to talk with every kind of people, because it's good to share ideas and learn about others' perspectives, right? So we should always be open to that. Anyway, so and then I also currently I'm in Chennai, the Institute of Mathematical Sciences, IMSc Chennai, for a summer project, for a summer internship project, and I talked with a lot of physicists here also. So and you don't need to talk to physicists, even by looking at the internet, by what is going on in academia. It's like this problem is becoming very obvious, and it's not a problem that we can sweep under the rug. It's not a problem that we can ignore anymore. So one thing is, number one, the most important problem, I think, is probably funding, but there is a deeper issue underlying that. Funding is probably the most superficial, the most prominent problem, but that's not the root problem, I should say. But anyway, let's talk about funding first. So when we talk about academia and society, first of all, these people in academia and the people in society, they have this kind of hate each other relationship. Maybe hate is a strong word, but yeah, usually what I've noticed, and it's true, like the ordinary people who don't do science, who don't do research, the people who are not in academia, the ordinary common people of society, they are like, what do these academicians or whatever, what do they do with so much money? Like, they get so much money in research grants, and they are building particle accelerators, particle colliders, and like this high cost machinery, and they're doing experiments. And in many countries, a lot of money goes into research grants. Maybe the situation is right now changing in some countries, you know what I mean, US, and even in India, the research grant funding is not that high. But yeah, it's still people question, maybe in India it's a lot of people question more than other countries actually, and that's not because of that's not a fault of India or the Indians, and that's not a fault of common people, because let me tell you both the sides of the story. I'm not trying to speak in favor of academicians and speak against common people. I'll speak in favor of both, because both have got a valid point. The issue is a misunderstanding between them. The issue is not one is right and the other is wrong. The issue is a misunderstanding. Both are right. Both have valid concerns. So anyway, now the point I would like to tell you is that, I would like to share with you is that, just my perspective, and I think you will be able to relate. So these common people say that why do the academicians get so much money from research grant, even if they find a new particle, or maybe if they find some new theory, some experimental validation of some like abstract mathematical theory, like theory of quantum gravity or something. How will that affect me? I'm just a common man. I barely have enough to eat. I barely have enough to feed my family. So they're taking crores of money and doing all this research. This is a valid concern. Indeed, a theory of everything, even if we find a mathematically consistent unique formulation of quantum gravity, indeed, how is that going to help a common man who doesn't even have like basic education? And that is not his fault, or his or her. That's not their fault that they don't have an education. Due to the unfortunately, we have not been able to address the issue of poverty. We have not been able to ensure free education for all. We have not been able to ensure basic human rights, right to education, even right to food, right to shelter. We have not been able to ensure this. So it's not their fault. It's our failure as a society as a whole. It's our failure. It's the failure of our system. So you cannot say that you don't know anything about physics. You have not even studied high school, so you are just an illiterate fool. So why should I talk with you? Just get lost. No scientist or no academician has the right to say this. That person is uneducated because of our fault as a whole. If that person was educated, if that person got the opportunity to have a proper education, then maybe he would be a better physicist than you are today. Yeah, and if he is from a rich family, if he had the option to pursue physics, pursue education, but he did not do that, he just decided to waste his life, that's okay, that's a different thing. But I think those kind of people will never raise a question about funding. I'm talking about the kind of the underprivileged people who have a very difficult life, the common people I'm talking about. So they are illiterate. It's our problem. We cannot say that you will not understand what's the importance of string theory, so I will not waste my time talking with you. You just get lost. You cannot say that. They have a right to know, because every goods, every product, every commodity we buy, they buy. Even a matchbox in India, it costs only ₹1. in Indian rupees. Just 1 rupee, it's the cheapest probably, or even those, I don't know, those pens or 5 rupee pen, even 3 rupee pens are also available in some places. I mean, even in these cheap products, there is it's written the MRP, the maximum retail price, is written inclusive of all taxes. So even the basic cheap products the people are buying, a part of that money is coming to taxes, and we get the research funds from these taxes. I'm here as a summer student. I'm getting a fellowship. It's a very less amount. It's not nothing like a PhD grant or something. Still getting some money. Previous year I was in PRL. I worked on some modular symmetry and kind of mathematical stuff, which was even it has very little application in physics, because it was mostly mathematical. It might have application in neutrino physics. Might have. I didn't have time to explore all of this. So even as a physics student, I couldn't see any direct application to physics. But I got like 25,000 rupees from the Indian Academy of Sciences for the project in 2 months. 12,500 in 1 month, so 25,000 overall. So that money, if you think about it, it's coming from the common people's pocket who don't have enough to eat. And I just used 25,000 to go to Ahmedabad, work on a project, and I don't know, maybe get a certificate, get a good exposure in research. But how is that helping common people? If you ask, it's not helping common people at all. I don't see how it's helping it, at least. Maybe after 100 years, some physicists will build a theory based on that, and then after 200 more years, we will get some experimental verification. After 300 more years, we'll have a theory of everything. After 400 more years, we'll find some innovation that will change society as a whole. These are just like fairy tale. It's nothing but fairy tale. You're building a castle with sand. This is not even a valid argument. If this is your argument for justifying your, I think, come on, we don't even know whether the world will exist after 100 years, the way things are going in this uncertain. I mean, yeah, even I am more inclined to theoretical physics than experimental stuff or applied stuff. In general, not just physics, I'm more inclined to theory than experiment. But even I acknowledge that the issues like the pressing issues, I mean, issues which threaten humankind, like climate change, poverty, wars, I mean, nuclear wars and all these things, they should be addressed much more urgently than maybe what goes on in that planet, or these deep fundamental questions. What is the nature of reality? These are all interesting questions, gives us intellectual satisfaction and all. And there are some people who will explore this. I myself hope to belong to that group, because that's what I'm comfortable with. I'm not really comfortable with experimental stuff, but I am not comfortable with experimental stuff or applied stuff or engineering stuff. That doesn't mean they're not important. They are much more important than the stuff that I do. I admit that, I acknowledge that. So yeah, this is one side of the story. The other side of the story is that, yeah, scientists have also got a point, because the tax money, it's not all the tax money comes to research grants. They're also wasted in a lot of other places. So if you think that research funding should be stopped, then you should first look at like all the places in which the money is going, and you will see that research funding is not really the worst way to spend money. I mean, of course, it might not have any direct benefit. I already told that. But then you should also question some other practices which goes on in most governments across the world. And of course, even if I leave alone the problem of corruption and all the government officials taking bribes and putting money inside their pockets, even if I leave that problem alone, even then the tax goes in a lot of places where it could be at least reduced. So I mean, it's okay if you have every right to question why so much money in research. How will research in theoretical physics, fundamental physics gonna help me? You have every right to question that. But my point is, research, don't just attack research grants only. That's not the only problem. If your problem is where are our money being spent and how is it benefiting us, you should look at the entire picture, not just research grant, because 100% of the tax money does not come to research. Very less percentage actually. Very less percentage comes to research actually. That's my point. And one more problem which I realized was that about academia is that problem in the sense it's a kind of debate, ongoing debate about publications and all. Like two issues. That's all I would like to say in this video. Like these two issues, and then I'll just stop, because I don't need to elongate it any further. Okay. So one is quality over quantity, or actually the other way around, quantity over quality. So nowadays I've been hearing of a lot of unfair practices, and this is this is outright hypocrisy. You submit a paper to a journal, like a big journal. I'm talking about journals of the stature of, I don't know, like maybe the big ones. I have no evidence, no particular evidence, so I will not take any names. But I'm talking about journals at the same level as even Nature or Scientific American, or those PRL, physical review letters for physics. It's PRL. Or, I mean, this level of journals. That Elsevier journals and all. I'm talking about this level. I'm not taking any names. But yeah, this level of journals. What is happening is, suppose you submit a manuscript, you submit your article, and then some like when it's published without even you being informed. I mean, you are not even informed, but when it's published, you have like I don't know, maybe 5 or 6 names as authors and co-authors. Maybe it was your own work, or maybe two of you submitted, you and your colleague, but when it's published there are 6 names. The other 4 people, you don't even know of them, you have not even been asked of anything or informed of this change, but they are saying that just randomly putting names there. Why? Because the other 4 people, they are in most of the cases what you will see, I think, is they belong to the same journal, or they're somehow or other affiliated with or related to the same journal, or they are very big names in academia who wants to add more citations and more like add more to their paper, to their resume, to their CV, to their profile. That's all they want. They have not helped anything. But and if you say that no, I don't want to like publish the paper with all these names because these guys, I don't know these guys, they have not helped in this research, you're like, your career is gone. You're like, okay, then don't publish, and that journal will block you forever. You cannot submit an article there. And most of these journals have tie-ups, so I think most of the other related journals will also reject your paper. And if you cannot publish, your career is gone as an academician, as someone in academia. Publish or perish. That's the thing. That is very wrong philosophy, but I think that's become the reality nowadays. It's publish or perish. And that is the reason people are not getting the time or chance to focus on a really fundamental issue, really big issue. They're just, see, if you work on something where like you can do some computation, you can do some simulation, you can run some code. Maybe you start with a very simple model. Maybe nonlinear dynamics, you start with a model about synchronized oscillators, like something like that. That's what I'm studying actually. That's why I said this, Kudamoto type oscillators, and then maybe you tamper some parameters. See, I held nonlinear dynamics in very high regard one, and no, it is very high regard because it's pure nonlinear dynamics is actually very high level mathematics and very logical. But the people who work in these kind of fields like computational biology and stuff, no offense, but the people who work in this kind of field, they just study some basic physics models and they just simulate that, and they just try tampering the parameters. Okay, what happens if I reduce this parameter and increase others, and they just do different simulations, different plots, and they just like build a theory out of that and they just publish a paper. It's very easy to publish papers if you work in these kind of things, because how long will it take? It will take 1 month. You just run some simulations and maybe just some writing and all, 2 months. So you can publish a lot of papers. And since one good thing about this field is that computational biology, nonlinear dynamics, biological systems, physics and all, is that it has got a lot of direct applications to society. A lot of applications in medicine, a lot of applications in biology. That's one good thing. It's interdisciplinary kind of thing. But it's easy to publish papers. Even astrophysics, you can just do some coding and stuff and you can publish a paper. I mean, you can at least write something, prepare something worth publication in a very short amount of time. And you can do this many times. That means you can have a lot of applications, quantity. And that's a good thing considering the career point of view, because you're in academia, you need a lot of publications to show. So quantity wise fine, but quality, the people who are working in foundations of quantum mechanics, they don't get any funding any days. They are, I feel sorry for those guys, but the pure mathematicians or pure theoretical physicists who are working in foundation problems, not any experimental. I met a lot of people here who used to work in these kind of problems, but even they are shifting to experimental domain. They have worked in quantum mechanics foundation, quantum information theory, like the theory part, not the application, not quantum communication systems, the quantum information theory, Bell's inequality, Leggett inequality, that kind of thing that guy has done for his entire life. Foundations of quantum mechanics, theoretical physics. But then he is like, now he's very old, but due to, I don't know why, but now he's slowly exploring experiments, suggesting experiments for better understanding quantum mechanics. Like he has shifted to experimental domain within quantum mechanics, but still experimental domain. So like that's what I was saying. If you really want to work on a theoretical problem, you first of all you have to understand the mathematics deeply. You have to think about the implications. It takes a lot of time. You cannot publish papers as frequently as if you work in just this kind of theoretical stuff, as compared to if you work in computational biology or whatever, this kind of stuff. That's what I'm saying. So quantity, but quality wise, those papers are often revolutionary papers. Often in the history of physics, all the papers which are revolutionary, you have not I don't think I've heard of a revolution in physics starting out of a random paper showing some particular simulations or computation. But revolutions have started off Anthony Leggett's paper, Leggett-Garg inequality, which is roughly speaking translates the temporal version of Bell's inequality. Not exactly, but yeah, kind of. Bell's inequality is about realism, and it's about local realism, and this is about non-invasiveness and macro realism. Anyway, so That was a very logical paper, and I think Leggett and Leggett Garg, they worked a lot of, they worked, I mean, it took a lot of time to arrive at that inequality. It's not just just like that, you know. It's not just they ran some codes, they did some simulation, and oh my god, here's the Leggett Garg inequality, let's publish the paper. It's not that simple, because you're talking about foundational issues in quantum mechanics. What are the assumptions which I will assume to be true? The particular choice of non-invasive measurability and this macro realism. There was a very detailed logic behind that, and then constructing the inequality, then showing how it might be violated theoretically. Were done later. Experiments. It takes a lot of time. So the guys are but it started off a revolution in quantum information. That's also true. Today, even experimentalists and the guys who work in quantum communication, quantum teleportation, quantum security, this quantum computation, encryption, decryption, they all use Leggett Garg inequality directly or indirectly. And then you can think about. I mean, the point is the guys who are working in foundational issues. For them, quality is very high, but yeah, quantity is less, and that is not that often is not favorable for their careers. It's a very very deadlock kind of situation. One last aspect I would like to discuss is about that thing. So, like when we talk about academia and all, open science versus peer-reviewed publication. So, usually scientists prefer peer-reviewed publications. If you have a publication in a peer-reviewed journal, that says a lot about you, because it has been reviewed by experienced editors, and it has been accepted and published. So it must be a very good paper. You must be very experienced in your field. It adds to your citations. It adds to your metric, H index, whatever, everything. That is good, but recently there is a shift which I am seeing with that towards open science. There are a lot of platforms like arXiv, preprints. I mean, these platforms are like maybe you have submitted your article for peer review, but peer review takes a lot of time, lot of time actually. So what you can do is that you can upload the preprint, because it's not yet the final published paper, because it may go through some edits during the peer review process. But in its present form, you can just upload it to some arXiv. Even arXiv, not anybody can upload to arXiv. To upload to arXiv, you need at least some amount of endorsement from people, and it also goes through a basic review. It's not a peer review, but it's a basic review. But you can upload to a lot of other platforms which are pretty good, like the MDP or something. They have a lot of this kind of facilities, preprints.org. Then there is Zenodo, which is funded by CERN actually, and European Union. So point is, these are just open platforms where you can just upload your work under your name. Of course, it will be written beside your work that this version is not peer reviewed, but anybody can read it, and it's just 1 second. Like, you just upload your work. Once you're ready, you just fill in the details, just click submit, it's published, and it has an official DOI, which is digital object identifier. So it's published there, and you don't need to wait 6 months or 7 months or 1 year for publication. So you can share your results with the world. That is open science. But yeah, speaking from the point of view of credibility, yeah, since anybody can upload anything, not anything. I mean, you cannot upload nonsense stuff. I think there are some basic measures in place, but yeah, it doesn't go through a rigorous check. So kind of anybody can upload anything as long as it is good enough, not the best, but good enough. Yeah. So since anybody can upload anything, having a it's not really an official publication. Having an upload or having some papers on Zenodo or even arXiv, that's not really a big thing. It's a good thing, but not a big thing. This is the usual the usual consensus presently. But I personally think that a shift towards open science is required from peer review because of two reasons. Let me be very logical. I'm not not arguing for the sake of arguing. Let me be very logical. Peer-reviewed publications to these big journals, you submit a paper today, in most cases it will, even if it's accepted and after revisions or not, it is usually published after 7 months, 8 months, 9 months, in some cases even over a year. So suppose you find some new results today and you submit your article today. Suppose just an imaginary example, you find something, some output. You predict a value to be 2, suppose, just an example, to be 2 units or something today, and you submit the paper, but the paper is like, it's going through and all. So, and after 2 months, another research group finds the same, does the same experiment, and they propose, they predict a value of 2.1 or 2.01, which is very close to your value, but they do this after 2 months of the day when you discovered it, when you predicted your value. But after 2 months, your paper is still not published. It's still stuck in the process. Let's say your paper is published after 9 months. But those guys, suppose they upload the paper to an open platform like Zenodo or something. So the world will know of their results first. Okay, so these guys, they found a value of 2.01, and then after maybe 7 months from that, your paper comes out from a from a very good journal, but it says that, oh, the value is like, I mean, see, of course, when your paper is published, the date will be there. It was submitted 9 months ago. It will be written submitted back then. So people will know that you submitted the paper long back and you were the first one. People will know that technically, but still the relevance of your paper is lost. The day the paper is going public to the audience, to the world, the relevance is lost, because people have already been doing this for many years, and they have already got better, more accurate results. You said 2, they said 2.01. Maybe more experiments have been carried out in between. That's the point I'm saying. Like, sometimes it takes a lot of time, and science is all about being open and collaborative. You should with the world. Science is not about secrets. I will not show my results to anyone else. It's like, there are people you need to be careful about. There are a lot of people who take your work and publish it as their own, and that kind of thing happens. This is very bad, especially between teachers and students, between faculty, professors and students, because then you cannot challenge them directly. That's also one problem. They have an advantage. So you need to be careful about that. But I mean, if you're uploading it to a preprint or a Zenode or anything, you have a registered DOI, and it's registered under your name, the date you uploaded, even the time you uploaded, everything is registered. So and if you upload there, most journals will accept your paper still, or maybe if you work on maybe if you have done some good work but basic work, maybe not worthy of publication to a big journal, just upload it to Zenode and or any open science platform, so that there will be a record at least that, okay, you did this under your name, and then you further work on that, and if you have very good result, to submit it to big journals. That's my point. So I have nothing against open science. Plus, sometimes the peer review process takes too long. The main objection against open science is that it's like, how will you verify? Because anybody can upload anything. That's the main objection. That's true to some extent. That's true. But my point is, see, the people who today, I know a lot of scientists, like a lot of serious scientists, professional scientists, they go to these open science platforms to look for papers, because even they know that some good scientists and some good professors, good scientists, they are preferring these open science platforms and are uploading the results. So open science platforms will essentially give you early access, which the journals will maybe publish after some months. So a lot of scientists consult these platforms, and my point is, okay, let me assume that out of 10 publications on Zenode, maybe two are like pseudo-scientific or not really scientific. Let me assume, fine. But my point is, the guy who is really a scientist, who is really expert in his field, he has the ability to filter out. He can filter out which is a paper worthy of reading and which is just a pseudo-scientific paper. So, I mean, the name, the platform, what journal have you published in, what is the impact factor, those are just materialistic issues. If you're really interested in science, you go to open science platform and you look for, there are very good papers there. There are some papers which are like nonsense as well, but you can filter that out. If you're expert in your field, you can filter out. So I think this argument against open science doesn't hold up. I mean, it doesn't defeat our purpose. You can filter that out anyway. What's the point waiting 9 months or 10 months for a publication? Just because, okay, I know, I admit you get that guarantee in journals that they will not publish anything nonsense, but even today, now we are seeing a lot of big journals are publishing AI generated paper and even obviously mistaken papers. So I think this sharp line between open science and this kind of peer reviewed publication, I think it's slowly blurring out, and I think there's a shift towards open science, which in my opinion is not necessarily a bad thing. So anyway, here in this video, I just wanted to randomly discuss a few points about academia and society as well. 3 points I mainly discussed. One is the apparent conflict between academia and society on research grants and money and funding. Second is about, this open science versus peer-reviewed publications. And the third point I discussed is about, the number of publications, quality over quantity, and all these unfair practices which are going on in academia. So, academia is very, very, very bad condition right now. The people who come to academia, they do that because they love academia. They don't come here for the money, even for the fame or glory, but they come here just expecting at least a good environment where they can explore topics. But even that is under threat nowadays. Such is the condition of academia, which is very, very unfortunate. But let's hope for the best. And if you have anything to share, please do so in the comments. Thank you guys. Thank you.